let's get into some of this. This is going to get in depth into how the brain works so we can understand how AGI works. I'm going to tie it back to AGI every time. All right, so low-level biological parts. We're going to get into those. All right, so some core features for AGI. We want to make sure that, like I said earlier, is autonomous. So it needs to have autonomy. It needs to have sensory systems. It needs to be continuous yet efficient, has an efficient learning system. This is one of the biggest things that people in the AGI community are trying to do is figure out what can I build that gives me an efficient learning system. Give me that, and they can work a long ways with it. And that's what they're trying to build. The recognition system, spatial and time awareness, basically a lot of semantic and episodic data. This is where compute is becoming a problem because there's so much data that we store here. It's about a petabyte of capacity just running through our brain at one time. Or they say petaflops. There is reasoning mechanism, emotion embedded into every memory. And then, of course, there's, last of all, identity and a theory of mind. Okay, so as we talked about earlier, we talked about the current state of ANI, which is AI we mentioned earlier, but now people are working on AGI. So we started out a long time ago, rule-based systems, which is, people call it AI, but it's not AI. It is basically just saying, hey, I have a closed domain of information, and it's retrieval-based. And what that means is I'll hard code in there, 1 million responses to things, right? And you'll have some prediction system that can try to predict what response fits. And that's typically the AI that some people still do today. A lot of chatbots kind of do that, which is not great, but they work. And that's why sometimes you hate some chatbots, because you start using them and they kind of give you the dumb answer. It's kind of because they're using that rule-based, kind of retrieval-based thing. The next thing you gotta have here is open domain, but retrieval-based. That's impossible to do, because that means you pretty much have to hard code every scenario in the entire world, which is just not any company with the most amount of money can do that. So that's off the table. But then you go over here to closed domain, and you start swooping up, because right now we have started doing generative-based responses, which is earlier I mentioned to you, all the models that we showed with the BERT and good stuff like that could also generalize. OpenAI has come out with different models that were able to generalize, but it's still kind of closed domain. So open domain is where they're working towards, whereas I'm able to have a learning mechanism that can learn anything, and then be able to generate a response to anything. And a response is not just a text or a word you say back, it's an action. It's an action to something that you were able to initially recognize. Like, I wake up in the morning, I recognize it's sunny, I realize that I'm late for work, so the action is jump out of bed and put my clothes on. You know what I mean? So it's a kind of that kind of continuous feedback between what I am recognizing and the action that I'm taking, or the response that I do from that. So we're going to break down cognition into multiple parts. Basically, cognition, like I said, is a capacity of how much your brain can do at one moment in time. Typically, we have like 1 petabyte, or these petaflops is a different term, or basically being able to push along 4.7 books of reading, basically 4.7 books at one time in your brain is the capacity you have to do something. Now, we don't use all of that because we don't need every neuron turned on, and then every synaptic connection turned on, as you learned earlier. However, you have that capacity if you were to turn on every synaptic connection in the entire brain. It's like basically using 1,000 computers and basically using 1 terabyte and have it all go through your network at one time. That's tough. Okay, so algorithms and intelligent AGI. So you need to make sure that it needs to be autonomous, cognitive, memory, processing, and recognition. All right, so system 1, system 2 brains. I'm sure you guys have heard of this before. System 1, of course, is the fast brain, the embedded knowledge you already know. Typically, they might say part of your limbic system, but you also have parts of your brain in your cortex as well that's been optimized. You learn something over and over and over again. That connection has been strengthened. The weights of that connection have been strengthened. And now when you do something and you've done it enough times, you don't have to think about it. It's already there. That is what System 1 does. And that feeling, say I got that gut feeling of this working out is because everything you've learned have made the connection that that is actually the right answer. System 2 is definitely much slower, but it's a smart part of the brain. It is where you are actually processing, reasoning, and figuring out something like you do the math problems you do at home or whatever that you did at lunch, trying to figure out solutions to problems. So that will help if we move forward. All right, so I kind of went over that already with the System 1 fast brain. The fast brain also, I want to note, is emotional. So that center of the brain is instinctual and fast, but is also emotional. That's where it is driven by. But in your complex slow brain, System 2, you make every decision decisive based upon thought processes. And we'll get into thoughts, but they literally talking about everything you do. You take a step, you try to make sure you do things the right way. System 2, it slows things down a bit. So let's move forward. All right, I think we talked about that.
What do the percentages refer to?
95% is typically how often you use that part of the brain, and 5% of the time and people say, oh, I use 10% of my brain or whatever like that. It's not physically using 10% or 5% and 95%. What it means is a lot of the 95% of the time, like you're driving to work, you don't think about driving to work, you kind of just do it. That's kind of like what that's doing. And the 5% of the time is when a car crash has happened and you kind of start realizing that's there, your brain's processing that and saying, now try to figure out what's going on. That's typically what happens with the 5%. And we need to have it that way because if we were at 100% all the time, learning processes would take forever for us to actually try to work through each day. So we say the 5% for things that are actually novel. And that's going to be useful in AGI. So old brain uses traditional neural networks. So what we learned earlier, traditional neural networks is based on the old brain. But the new brain uses higher order, which begins to use probabilistic and regression systems. So the difference between a neural network and probability or regression is that neural networks are deterministic. You have to come to some solution, something at the end. But when you're dealing with higher order or new brain systems, you want to use probabilistic or regression systems that are able to correlate something or some answer that you yet don't know. And you have to test that hypothesis to see if it's right or not. So, move forward on that. So anyway, use System 1 and System 2. I mentioned that. It starts out with System 1. And then System 2 takes over when System 1 doesn't know what's going on. So System 1 is thinking, okay, I realize that there's a car crash. I don't know what's going on here. System 2 takes over, and your brain starts functioning at a much higher level. And you see these on MRI scans. Okay, so we'll get into memory types. Sensory memory. The sensory memory, there is working memory, short-term memory, and long-term memory. These memories do not reside in your brain. They don't actually sit somewhere in your head somewhere. They are the patterning that is going through the neural network is the sense of memory. The memory is the process, not the actual physical state. So there's nothing physically there. It's encoded in your brain, and the process of it channeling through my brain is the physical memory. So when we go through the actual neural network earlier, when you saw that it actually traveled through certain nodes and get into the end, that's actually similar to how we work. We have a traveling process that when we first see something come through our brain, either the visual or auditory typically, it comes through and finally hits to the hippocampus, which is where our memories are encoded. That process is literally the memory. Okay, so AGI and working memory. So AGI, so basically the working memory part of the brain is where all the work is done. Is kind of where the cognition kind of kicks in. And because we have thoughts every moment of time, basically a thought per second. It's kind of how it works in our brains, and that's driven by our working memory. Working memory does a few things. It handles both the kind of a separate different paradigms because it works with system 1 and system 2, but it also works with the old brain and the new brain all at the same time. So your thoughts are traveling through different parts of your brain.